Today I am going to discuss about the power of a lens. So lenses generally are of two types. One is the concave lens, other is a convex lens. Concave lens is also known as diverging lens, and convex lens is known as converging lens. It converges the rays at a point, and diverging lens, it diverges the rays at a point, like this it is. So the ability of a lens to converge or diverge rays, listen me, the ability of a lens to converge or diverge light rays depends upon the focal length. Okay, focal length plays an important role in converging or diverging light rays. Now, for example, a convex lens of short focal length. Okay, convex lens जिसका focal length छोटा है. Okay, bends the light rays through a large angles. Bends the light through large angles by focusing them close to the optical center. So a short focal length converge rays with large angles. मतलब उसमें कन्वर्जेंस ज़्यादा होता है. अगर फोकल लेंथ छोटा है, कन्वर्जेंस ज़्यादा है. Now, similarly, okay, concave lens of a short focal length causes high divergence, okay, than with longer focal length. And जिसका फोकल लेंथ छोटा है, okay, जिस कनकेव लेंस का फोकल लेंथ छोटा है, वो रेज को ज़्यादा डाइवर्ज करेगा, लार्ज एंगल्स से वो डाइवर्ज करेगा. ठीक है, आया ठीक है. So now, so what is power it is here? So the degree of convergence, how much, the degree of convergence or divergence of light rays achieved by a lens is expressed in terms of power. Is power. Powers means, okay, how much a lens converges a rays, or how much, okay, a concave lens diverge rays, light rays it is here, and that is measured by power. So the power of a lens is defined as the reciprocal of the focal length. Yes, reciprocal of focal length. So it is represented by capital letter P, and the power P of the lens of focal length F is given by P is equal to 1 by F. I am just showing you in a board. So power is indirectly proportional to the focal length. So this I am showing you. So P is equal to 1 by F. It is F, 1 by F. See here. So P is the power. P is equal to power, and F is equal to focal length. Focal length, it is C here. P is equal to 1 by F. It is like this. P is equal to 1 by F. Clear? Means, okay, when the focal length is small, the power will be more. When the focal length is big, the power will be less it is. So the power is indirectly proportional to the focal length. More focal length, less power, and less focal length, more power. It's okay? Clear? And one important, while calculating power, we must have to change focal length into in meter. We must have to change the focal length into meter. If it is in centimeter, we'll have to change this into meter it is. So I can just give you one formula for finding the power when the focal length is in centimeters. So you can just put 100 by f, it is power is equal to 100 by f. You can say like this, it is if if f is in centimeter, like this, 100 by f, see like this, it is like this, okay, like this. Yes. And suppose there are several lenses are there, several lenses are there, several lenses. So what is the combination of all the lenses? Okay, so the combination of all the lenses is a simple addition of all, the combination of power of all the lenses together is a simple addition of all the powers of a lens. It is, so it is like this, P2 plus P3 plus, it is like this, like this, it is here, P, see here, P is equal to P1 plus P2 plus 3 P4, like this it is. Whether it is concave or convex, it doesn't matter, doesn't matter. Okay, so the power, resultant power of all the lenses together, P is given by P1, P2, P3, P4, like this it is. So it is for concave or convex lens, both it is here. If it is mixed one, suppose some are convex and some are concave, even though you can add the power and you get the resultant power. Resultant power you can get, it's like this. Clear? So in this way we can find power of a combined lenses. Now the SI unit of power is diopter. It is diopter and it is denoted by capital D. It is denoted by capital D, diopter. It's denoted by capital D, just I'm showing you diopter. It is an SI unit. It is capital D, it is C here. Diopters it is. Okay, diopter. So how can you define one diopter? Okay, so like so one diopter is the power of a lens whose focal length is 1 meter. Okay, simple. How will you define one diopter? So one diopter is defined as the power of a lens whose focal length is 1 meter. It's okay. And suppose so that is the definition of one diopter. So now one thing I'm going to tell you about the plus sign and the minus sign in diopter. Suppose a student is wearing plus 2.0 diopter lens. In it here, it means that the plus sign means the lens is convex, and if it is minus 2.5 minus sign, this indicates that it is a concave lens. So in finding power, we usually write plus for convex lens and minus for concave lenses. Okay. Usually those who are not been able to see clearly the far off objects, they wear concave lenses. And the power is -1. And those who are not able to watch or see nearby objects, for example, generally in old people, you might have seen, okay, you might have seen this. I think I made a mistake here now. Okay, the people who are not been able to see the long, objects, far off objects, so they wear concave lenses, and those who are not been able to watch or see nearby objects, so they wear convex lenses. Okay, and their power is positive. for old people who are not been able to see clearly the nearby objects, so they wear convex lenses, right? Generally, uh, children usually they wear these concave lenses having focal length having this power negative, and the old people wear positive lenses, means they are so that is convex lens it is. Okay, so power may be positive or negative, that depends upon the kind of lenses. Once again I am clear here. Positive power means the lens is convex, and the negative power means the lens is concave. Now there is a question here now. A doctor has prescribed a corrective lens of power plus 1.5 diopter. The doctor has prescribed a lens, corrective lens, and the power is plus 1.5 diopter. Now question is to find the focal length of the lens. To find the focal length of the lens. Is a prescribed lens diverging or converging? Is it diverging or converging? Simple it is now. So the plus power is there, no? So it is converging. Isn't it here? Plus power, it is converging, means convex lens it is. And how to find the focal length? Focal length you can find this way. So focal length is equal to, using the power formulas, P is equal to C here now. This is given here now, this is given. So P is equal to 1 by F, and F is equal to 1 by P, and the P is given 1.5 diopter. Okay, so the decimal has been removed, so 10 has gone up, and in order to make it, this is centimeter, this is centimeter, this is centimeter. In order to make it centimeter, okay, I multiply it by 100, and the answer is 200 by 3. You can convert it in decimal, you will get how much you will get. You will get about 67 point some 67.6 you will get, isn't it here? 6 if you divide 6 3 is 18, 6 is 67.6 or 67.7 centimeter. The focal length is this. Focal length is this. You can see what it is. Like this it is. This it is. Today only this much. Watch it, and I hope you like it. Thank you very much.